Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts related to the sensor and its classification, applications, along with the radar, LiDAR and SAR. Here, the remote sensing sensors are classified into passive sensors and active sensors based on the source of electromagnetic energy which is used for the observation. Here, the sensor is a device designed to record electromagnetic radiation, which consists of optical components to focus the observed data or area onto a plane of detectors that produce outputs in the representative of the terrain. The core variables which are useful for that purposes are energy source, platform, spectral range and imaging mechanism. Likewise, that passive sensors record naturally reflected or emitted energy, while active sensors generate and transmit their own energy toward the target. The sensor classification helps determine the suitability of data for different engineering and environmental applications. So the sensor system basically are of the three types: multispectral sensing system, thermal sensing system and microwave radar system. Here the multispectral sensing system is divided into photographic system and scanning system based on some specific objectives which are required with reference to the engineering domain. Here the classification of based on energy source, that is passive and active, where the source of light is most important. That passive sensors depend on solar radiation or naturally emitted thermal energy from earth's surface. They operate mainly in the visible near infrared and thermal infrared regions of the electromagnetic spectrum. The common examples which include that the cameras, multispectral scanner and thermal sensors on board Earth observation satellites. With reference to civil engineering applications, they include that land use mapping, urban planning and environmental assessment and watershed studies. Here, that passive sensors and active sensors are most useful for the collection of data with reference to the system or imagery. Second one will be the classification based on some platform. These platforms are of here the active sensors, they transmit their own electromagnetic energy and measure the reflected signal from surface feature. These active sensor system can operate day and night and are less affected by atmospheric conditions. Radar, LiDAR and SAR are the important examples of active remote sensing technologies. The civil engineers use that active remote sensors for terrain analysis, infrastructure monitoring, flood mapping and deformation studies. Second one, classification, which is most important on the base of platform, that are from the space to ground, which is divided into orbital point of view or altitude point of view also. The data which is on the earth's surface with reference to the geodetic curvature of the earth. The space borne satellites are there, then airborne satellites or aerial vehicles or aircrafts, or we can say that the drones are used, and data is on the earth's surface. The sun synchronous orbit is or at up to the 700 to 900 kilometer altitude. That is the Landsat satellite, which is useful for that consistent illumination purposes. Then second one will be the geostationary orbit. That is, it is at up to 36,000 kilometer altitude, which is the stationary relative to the Earth for the meteorological characteristics and data collection. Next one will be the low to high altitude point of view. The platforms are divided into high spatial resolutions for limited coverage, and likewise. And at the ground platform, 0 to 30 meter, that is the field spectroscopy and ground truthing. We can collect the data by using some advanced surveying instruments with reference to the remote sensing and GIS point of view also. Third classification, which is based on the spectral range. That spectral range is divided into basically the zones, or we can say that the light which is visible to the naked eye, that is the visible light only, but the another waves are of the reflected infrared, X waves, gamma rays, ultraviolet rays, microwave waves, and many more thermal waves also. So zone 1 is the optical spectrum, zone 2 which is the thermal spectrum, zone 3 will be the microwave spectrum. Likewise, that have each and every value, that is 0.4 to 3 micrometer for zone 1, then 3 to 14 micrometer for zone 2, and next one will be the 1 mm to 1 meter for zone 3. Means we can use that electromagnetic spectrum for dividing the frequency ranges from 300 gigahertz to 0.3 gigahertz. Likewise, the spectral range classification, that sensors are divided or classified, and we can select or use that sensors as per our requirement for the project. Next classification, based on the imaging and mechanism point of view, here the two types of the system based on the scanning, where photographic, that is the frame system, and second one will be the scanning system. Here the photographic or frame system, which includes that the image capture based on some instantaneous field of view at a time with reference to its position or with reference to its angle or direction. Here, the detector's point of view, we can use the analog film or digital matrix for the data, so that that geometry which is based on the central perspective where distortion at edges is shown, there will not be any oblique angle, that is the exact vertical photograph will be taken by using that frame system. Where the scanning system, which is based on some image, is built sequentially, that is by line or by the pixel format. Here the whole passage of swath on the earth surface will be covered by the line texture with the linear arrays and single detectors. Means we have the data on the basis of electronic transmission, wider spectral range of radiometric calibration, so that the whole data which will be classified on the basis of imaging mechanism. Type of sensor are the optical sensors. There are the two types of optical sensors, visible and near infrared sensors. So here the concept of the graphical representation, spectral reflectance curve, which explains with reference to the wavelength and reflectance or percentage of reflectance. Here the soil, water and vegetative material is considered for the factor point of view. That optical sensors are working on the principle of solar reflectance, where the spectral bands are most important to be focused with reference to multispectral and hyperspectral way. In multispectral point of view, view ground through discrete narrow bands, means just we have to divide the bands with reference to its width, that is narrow, so that the blue, green, red, near infrared, likewise we can divide with reference to its color. So the differentiation of vegetative health occurs here, which is shown in the graphical representation, where the exact increment in the green healthy vegetation, which will be marked with reference to its unhealthy vegetative soil. That means the hyperspectral, where hundreds of continuous narrow bands are studied. Means in multispectral there are minimum bands, but in hyperspectral there are hundreds of bands are studied at the same time by that optical sensors with reference to its visibility and with reference to its near infrared range, with reference to the reflectance or degree of reflectance or the percentage of reflectance. Next type of sensors are the thermal sensors. Basically that thermal sensors are working on the Planck's law or the Wein's displacement law, where the graphical representation of wavelength with reference to the spectral exitance is studied. That body or that diagram, which is known as a black body radiation curve, with reference to that we see the two curves, one is in brown color, one is in green color. The brown color curve, which is showing the peak of 0.5 micrometer, but it get tilted nearby to the 0.1 micrometer wavelength, whereas the green color, which is exact symmetrical with reference to the spectral exitance of 10, that is 9.7 micrometer wavelength, means that thermal sensing system, which is studied on the basis of physics of emission, where the all objects are greater than 0 degree Kinematics emission with reference to its radiation point of view. Here the sensors, they are used to detect the radiant temperature or variation in temperature which is derived from kinetic temperature and emissivity. At the same time, we can use or we can take the consideration for the operational purposes for the day and night capability where the source is the object, not the sun. Also that we can use the detectors point of view where cool quantum or photon detectors are studied just like the HGCDT to minimize the system noise and other systems likewise. Basically that sensors or all the sensors are working for the study of temperature where the visible bands are used to from range 0.4 to 0.7 to study the actual thermal changes or variation. Next are the microwave sensors. Basically that microwave sensors are dependent on the optical waves or on the microwave pulses. Here in optical waves we can see that microwave sensors by visible or near infrared range where source of light is there, and with reference to that source of light the large amount of rays are emitting and they are reaching towards the clouds. Basically these clouds are the obstacles for that waves. But with reference to the any ground station or antenna point of view, if we study that microwave pulses have 1 micrometer to 1 meter length or frequency, we can say that, where that emitted rays from the ground stations can travel through that clouds or can travel through the clouds and reach towards the ground surface with reference to its geodetic curvature. So basically that microwave sensors are of two type, passive microwave and active microwave. That passive microwave which is known as a radiometry, where active microwave which is based on the radar system. So here the detectors naturally emitted are faint so that the microwave energy is detected passively with reference to the radiometry in passive microwave with the determining factor like temperature, dielectric properties, for example that soil moisture and other other soil components. Likewise low spatial resolutions are used to take the data or check the sensors, while the active microwave sensors are dependent on the radar which is advancement where the pulses are transmitted and the backscattering effect is also measured with the same, where all weather advantages for the radar point of view because wavelengths are from 1 micrometer to 1 meter, so 1 millimeter to 1 meter which is exceed atmospheric particle size. Scanning mechanisms, that is whisk bomb to push bomb, two types, across track and along the track. Across track is nothing but a whisk broom, while along track is nothing but a push broom. Here the rotating mirror is to the satellite portion which is exactly above to the earth surface. The earth surface is divided into the direction of motion and ground swath where the pixel by pixel construction activity is carried out to detect the data or to take the images or data collection point of view. But in push boom technique, along the track we are traveling the whole liner detector array or satellites with reference to the linear array, and that line by line construction covers whole the ground swath in the longer dwell time with reference to the direction of motion, so that the push broom offers better radiometric resolution with the structural stability, means there will be a no moving parts situation will study. Next are the radar sensors. They are based on the synthetic aperture radar, that is active ranging point of view we can study with reference to the exact vertical, exact horizontal or with reference to the oblique angle we can collect the data of the nadir point or of any other ground ranges or ground swath with reference to the oblique angle also. So ranging principle which is based on the distance is equal to speed of light into time or time delay, where the side looking geometry is most important concept based on that radar sensors where which is required to resolve ground features based on the time delay differences. Here the interaction which is based on some radio detection and ranging point of view where the ground and its properties like roughness are studied with reference to its surface, that is bright return, that is backscattering effect, smooth surface where dark, that is specular reflection away. Means for rough surface the backscattering effect is there, for smooth surfaces we can see that the specular reflection point of view. So here one of the interaction point of view we can see the polarization also, where orientation of electric field is studied by using some radar sensors, so that the interaction is studied with reference to the soil characteristics or the earth surface or with reference to the electric field which is available nearby to that location or the coordinates. That LiDAR is an active remote sensing technology that uses laser pulses to measure distances to object. That system which is based on the mechanism of active optical sensor, that are laser pulses which are available in green or near infrared region. The time of flight of the laser pulse which is measured by using that LiDAR technique. Millions of measurements are collected to generate highly accurate 3D point clouds. So civil engineers use that LiDAR for topographic mapping, terrain modeling and infrastructural surveys. With reference to that LiDAR, a LiDAR is a system which includes laser scanner, GPS receiver, initial measurement, or we can take that initial measurement by using inertial measurement unit and data processing systems. That laser pulses are emitted towards the surface and return times are used to calculate the elevations also with reference to the z coordinate. The accurate positioning information allows creation of precision 3D dimensional surface or 3D models for any region. This technology which provides highly detailed elevation data in engineering analysis. So applications of the LiDAR radar systems or sensors systems with reference to the each and every domain in engineering like urban planning, water resources and route alignment and many more. For urban planning, the monitoring urban growth, informal settlements and encroachment on arable land, we can monitor with reference to that sensors technique, where the water resource engineering apply them for floodplain delineation, watershed analysis and drainage studies for the mapping drainage patterns and flood prone areas also. Likewise, the geotechnical investigations we can carry out with reference to the synthetic aperture radar and LiDAR technique for landslide and ground deformation monitoring. For urban planning point of view, we can use it for high resolution spatial data for infrastructural development and smart city objects or any projects. Where transportation or route alignment point of view, we can use the technologies for route planning, corridor mapping and construction monitoring, where preliminary planning for roadways or railways which is carried out by the cutting and filling estimation using satellite topography and digital elevation model with reference to it. So what are the advantages and limitations for that? Advantages are based on the four topics, that is hypnotic view, repetitivity, accessibility and cost efficiency. Where the disadvantages, or we can say that the limitations, which are of the three types, that are three domains: atmospheric effects, resolution trade-offs and complexity. Basically the advantages are more with reference to that limitations, because this is the advancement in the actual data collection point of view or the open source satellite point of view. We can use that all satellites on the basis of sensors, and that all sensors are most feasible and updated with reference to its repetitivity of data collection, continuous data collection, accessibility with reference to the map, remote location or any dangerous terrain point of view. Also we can use the data capturing methodology. So moving towards the summary point of view, the sensors are classified as a passive and active systems, each providing unique advantages for remote sensing applications. Basically, the radar and SAR, they are offering all-weather monitoring capabilities, while LiDAR provides highly accurate three-dimensional measurements only. So these technologies significantly improve mapping and monitoring and analysis of engineering projects. In civil engineering point of view, we use that radar, LiDAR and SAR. They are playing crucial role nowadays for the planning, design and hazard assessment point of view, or also in the infrastructural management domain also. So effective remote sensing which requires matching the sensors capabilities. There may be a spectral basis or there may be a spatial resolution basis with the target characteristics and environmental conditions also. Stay tuned guys. Happy learning.